Okay, so now we're into chapter 13 stuff. So specificity is built on the idea that binding is preferred. And we will call the preferred receptor our primary receptor. Or R sub naught. R naught is our primary receptor. Okay, and so we could write this association reaction of our primary receptor. We have our ligand going to our complex, and Kd for our primary receptor is R naught, concentration of free ligand over the complex. And then we suppose that there are n set of secondary receptors given by R sub I. And these can also bind to our ligand of interest. And we can write a case of D, the dissociation constant for these. So just keep in mind I'm writing this as the binding reaction and then I'm writing Kd here, so. So this concentration of this receptor, concentration of ligand, concentration of our complex. So this is our target, and this is off target. In this situation, our ligand is the same in both equations. It binds simultaneously to all the receptors present. I mean, I guess theoretically every ligand can bind to every receptor, but some of them are going to be at those like not measurable levels. And all of our equilibrium equations would also have to be satisfied. So we're going to define specificity factor, which we're going to denote alpha as the concentration of the primary complex over the sum, I is going from 1 to n number of secondary targets, the concentrations of all of those complexes. Okay. So take the sum over all the off target receptors. Now this equation, just as it's written, totally works. It's totally valid. The problem is that this is really hard to measure, as we already talked about with our binding assays. The whole essence of scattered analysis was to get things in terms of ligand, because actually measuring receptor bound concentration, especially when we have a whole bunch of them happening in the same reaction vessel, is really hard to measure and control. And so again, we want to come up with a way to rewrite this to make it easier for ourselves. Okay, so by conservation, so like I said, this is just very difficult to measure experimentally. Okay, so by conservation, our total amount of secondary receptor, or of any given secondary receptor, will be equal to the free concentration plus the bound concentration. So from up above here, from our relationships to KD, this piece is equal to the complex concentration times KD for that off target for a ligand concentration. It's just a rearrangement of this. Same thing, rearrange. Ligand concentration over dissociation constant for that receptor. So rearrangements of those two equations. And then what I want to do, not only am I going to plug those two things in for here, I'm also going to write it in terms of this now, so I'm moving this over. So now I have the concentration of my off-target complex is equal to the total concentration of that minus the complex concentration times the ligand concentration all over. And then I rearrange it 3 more times. How much time do we have? Like all of these proofs and all of the step-by-step algebraic manipulation is in the book. So it's like I hate to spend time on it. Because one, I believe you do know how to manipulate equations, or I hope you do. But, alright, so this is just a rearrangement. I will say this, I mean, I don't know if it's a time-related factor, but there definitely are some people struggling to do algebraic rearrangement on the exam, things that are just dividing or subtracting from one side to the other, or like you're just picking one or the other, like basic math moves. Or now we're gonna multiply, now we're gonna add it, and I don't really know. I'm hoping it's just a bit of time crunch and a bit of panic, and that, you know, it's not happening on homework, so you're fine. Okay, so here's our first rearrangement. We're gonna rearrange again. Remember, this is really, we can't really solve for this easily. So now we have the total concentration. Remember, we had a way to get this with scatter. 1 plus AD by I over ligand. Okay. So we have put everything in terms of concentration and affinities, to now calculate specificity. Okay, so this piece here, we're just going to go back in and plug it to alpha. Alpha will be equal to our primary concentration, our total amount of primary receptor over 1 plus dissociation constant for our primary receptor over our ligand concentration, which again, we have control. I equals 1 over 10. We're still going to sum over all the possible off-target sites. So we talked about we can use some of our binding assays to get us this piece, to get us this piece. We can use Scatcherd. Okay. This is the equation you will be expected to use when you're asked to calculate specificity. Is moving up good, or do you need zooming? Listen, there it is in all its glory. Okay, when alpha is high, we have high specificity. Okay, for our target receptor. When alpha is low, we're getting more off-target binding. Or we should expect to find more off-target binding. Okay. But note, alpha depends on ligand concentration. And as you vary ligand concentration, what's going on with off-target binding might change. I'll give you a second to copy before I move on.